Okay, so the problem we're investigating here is mostly about how the microscope is going to help us to see things. Okay, so what's inside the microscope? Lenses. What do lenses do? How? How do they magnify? What do they do to light? Okay, they direct the light. They change the path of the light. And if you machine a piece of glass to the right shape, okay, you can bend the light so that it does what you want, right? You might want to converge the light. That if you burned ants with a magnifying glass when you were a kid, that's what you were doing, okay? You were converging all the light that landed on the lens to one little point of hot intensity, okay? That's what the lens was doing. It was directing all of the light rays that came into it to a single point. Now, if we want to enlarge something, we don't want to be looking at the single point because that would be very small. Instead, we want to enlarge it. Okay, we want the light rays to be diverged so that when we look at what we're looking at under the microscope, it appears to be bigger. All right, so that's something that we'll have to talk about in our hypothesis probably, is how the lenses help to make something bigger. All right. Now, our manipulated variable, responding variable, controlled variables. We're going to be looking at 4 different things. All right, we're going to be looking at the letter E, paramecium, a euglena, and an amoeba. Okay, because what we're trying to find out is, does it matter what I'm looking at? Does the microscope does the microscope do the same thing to whatever it is I'm looking at? Okay, so in order to know that, we have to look at different things. Okay. Now, we're trying to find out how the microscope works, so our responding variable probably has something to do with how things look through the microscope. I wouldn't word it like that. I would use more scientific wording than how stuff looks through the microscope. Okay, there's another word, I think it starts with A, that has something to do with that. Okay, but that's kind of what we're looking for here. Our results are what we see in the microscope. Okay, and then our control variables, things that remain the same every time we look through the microscope. Now, these have to be things that actually affect the microscope. Temperature doesn't really affect the microscope very much, so that's not going to be a control variable this time. Okay, but we're probably using a similar technique every time we view a specimen under the microscope, right? We're going to be focusing it in a similar way, right? Things like that. Anything that you do that's the same. The lens, the slides, other than what's on them, are all the same. They're all pieces of glass, okay, stuff like that. Right? Anything that could alter what the image looks like needs to be controlled. Questions on the variables? You can see I'm kind of giving you less detail. I'm weaning you off of me giving it to you every time, right? Okay. For our hypothesis, we got to generate a hypothesis about how a microscope works and what characteristics the images will have. Okay, so I would say then that how the microscope works probably needs to be the if part. Okay, and what characteristics would need to be discussed in the then part. Okay, the and part obviously talks about what we're doing in this lab, which is looking at stuff through a microscope. Say it different than that though. All right. Okay, so we talked about just a few minutes ago about lenses, okay, and light and what lenses do to light and how that can make things bigger. All right, don't be afraid to Google that too if you want a better explanation than what I did. That might help you learn it a little bit, and that's not cheating, by the way. Okay, so those are things to look for. So our procedure, okay, not that it's going to matter for today, but you get the microscope. It says get the necessary slides. We'll actually only take one slide back to our table at a time because I found that when you have many slides on the table, it's very easy for them to get pushed off the table and onto the floor. So we only take one slide back at a time. Okay, when we're viewing the slides, we make lab drawings. Well, we can actually take pictures, okay, of the letter E, the paramecium, euglena, and amoeba, and then make lab drawings of them. All right, and each group member will make a wet mount. Well, not each group member. Each group will make a wet mount of the letter E and view it under the microscope. How many people have made a wet mount or a microscope slide themselves before? Okay, a few of you. All right, it's not difficult. It's not like a highly technical procedure of any kind. Making a wet mount, there's your microscope slides, a little rectangular piece of glass looked at from the side. All right. I'll cut a little letter E out, okay, of a newspaper, of the article, not from a headline, so it's nice and small, okay, and then I'll place that right here on the slide. Okay, so it'll be laying kind of flat on top of the slide. So right there. Then I'm going to add a drop of water, hence the name wet mount. Okay, I'm going to add that drop of water onto the letter E, at which time the letter E will probably flip over, okay, and be all out of whack and not the way you want it. That's fine. You need it to soak up some water anyway. So just kind of press it down with your pencil, or with you can get a probe from the dissecting kits if you want. Okay, but in the end, what I want to see on your slide, so looking at it from the top, is the letter E like this on your slide. Right? That's the way it needs to go into the microscope. All right? So right side up, if I'm looking through the microscope, I want to see the letter E in front of my face, right side up. I put it in the microscope that way. Right? Because part of what we want to do is see what happens when the lenses are doing what we think they do. Okay? They might not just make the thing bigger, they might also alter how it appears. Okay? Because of what happens with the light. There's more than one lens in there. All right, so we'll have it on there, okay, and then we put the drop of water on, so we'll have this kind of little bubble of water that's on the slide. Then we take a little plastic cover slip, which is just a little clear, thin piece of plastic, which incidentally you do need to be a little bit careful with. The edges of it can cut you, okay, just like paper. The edge of paper can cut you. The edges of these little things, if you're not careful with them, okay, could cut you. So you set it at an angle like this, and then you drop it on, and it just falls down onto there, squishes the water to the edges, and sticks. Okay? Why do we bother putting a cover slip on? Okay, no stuff gets in the water. That's part of it. Doesn't fall off. Yeah, because I mean, if you're looking at like a letter E, or it's a little tiny clipping of newspaper, if you were to sneeze or breathe heavy, it would fly away. Okay. Right, it'll stick and it won't move around, so whatever you're looking at is kind of stuck in one place. Okay, but the biggest reason is if I've got a wet mount, I've got water on a slide. I don't want my lenses getting into the goop. All right, if I was looking at a blood sample, I wouldn't want to get my lens touching the blood. How would I clean that off of the lens after, right? So the cover slip is there to protect the microscope itself. All right. Why does it stick? You can think about that. I don't want the answer because it's actually part of your analysis questions. I want you to think about why that might stick. You put water in there. Talked about some stuff to do with water in the last unit. It's kind of special. It's on your exam too. Okay. Yeah. Okay. So you add the water in. That's how you make the wet mount. You're only doing one wet mount. The other ones are all prepared already for you. You just grab the slides and stick them under the microscope. Okay. So the analysis questions. Okay. Using what we saw under the microscope: size, orientation, general characteristics. Explain what you think happened to enlarge the specimen. So what I mean by this question is, okay, talk about the path of the light. Okay, talk about, it came from the light source, and then it went through the specimen. Then where did it go after that? Okay, what happened to it? And as a result, why did things look the way they did? And incidentally, this is why we're looking at the letter E, and why I'm making such a big deal out of make sure it's right side up when you put it in the microscope. Okay, its orientation is probably going to change as a result of the light coming from it going through the lenses. Okay, so that's going to help us figure that out. Okay, for number 2, describe and explain the steps you took to find and focus your paramecium. So what I mean by that is, I put the slide in the lens, or on the microscope, sorry, and then I found it, then I did this, and then I did this. So to just talk about the order in which you did things. Okay, and then thirdly, why did we add water to the wet mount? Right. For our conclusion, state a conclusion that relates to the problem and your hypothesis. Were you right or wrong? Okay, based on what you said, did the light follow the path that you predicted? Did the lenses do what you thought they did? Okay, and then sources of error. I would say I'm going to give you one. That's a legitimate source of error: inexperience. Okay, you guys have probably not used a microscope all that often in your life. Okay, and so as a result, you need some practice at it. And so the first time you use it, just like anything else, you're not going to be all that good at it. Okay, the first time it's going to take you a little while to really get the hang of focusing stuff. Okay, people are always calling me over, Mr. Gooder, I can't get it focused, and then I've got it done in 2 seconds. Okay, it's not my first rodeo. Okay, so it just comes with practice. Okay, you get good at it. All right, questions on that stuff? Okay, just want to quickly outline how you do the picture thing for your lab drawings. Okay. Okay, so you have to make a new page for each lab drawing. It needs to take up a whole page on its own. Okay, so I've inserted a page break, and now I have this page here, right, and I'm just going to show you guys how you can insert those pictures. So first off, you take the picture with your camera, and there's a couple of ways you can get those pictures into your Google Drive. All right, you can use the Google Drive app on your phone. It's got a Google Photos thing, but it will try to upload all of your photos, and you don't want that. Okay, but if you're doing that at home, it's not all that bad. Probably the best way is just to email it to yourself. Okay, so you take the picture with your phone and then email it to your Isidore account and then save that picture in your Google Drive. All right, so what I want to do right now is I want to insert an image. Okay, and then it'll ask me, do you want to take a snapshot? Do you have it on a website? Do you want to look in your albums or on your Google Drive? Okay, and I'm just going to say I'm going to look on my Google Drive because I know that there's a picture of an amoeba there, because I put it there. Okay, so I'm going to say, okay, I want to use this one, so I just double click it, right, and it puts it in there. Right, now you can wrap the text around it. Okay, you can break the text and things like that, but the difficult part now becomes the labeling. Okay, inserting the picture is easy enough. Okay, but remember we got to put our name and date in the top right corner over here. Right, so you got to move the picture around a bit. So we're going to say wrap text, and then that usually allows you to move. Just click and drag and move that around. Okay, so if I want my name to be over on that side, then I go with the justification here, which isn't showing up, but you can have it all justified over to this side. Put your name and date over there, and then usually you can insert horizontal lines. Okay, and you can move them around. Of course, it's not letting me do it right now. Okay. Your other option would be if you're at home and you're working on this, you could doctor it all up in like Paint, okay, or any other kind of low-end graphics program. You could just draw all the horizontal lines on in there and even do the labeling on there, save that picture on your Google Drive, and then just pop it in on here. Whichever way you want to do it is fine with me. Again, if you want to take a picture, print the picture, draw the labels on, snap another picture of it and insert it that way, I'm fine with that too. Okay, whichever way, as long as you get it on there in the right format. Danielle, you had a question? That was okay. Okay, so any of those options are fine. Okay, just make sure that you've got lab drawings of all the 4 things that we're going to do. Okay, so incidentally, that's what some amoebas look like. Every amoeba looks different because they're a purple blob. Okay, and it kind of depends what they were doing at the time they got put on the slide, what shape they have. Incidentally, all the things you're going to be looking at tomorrow are dead. Okay, so they're not going to be moving around on the slides. They're cemented onto the slide. Okay. All right, questions? All right, you have, oh man, close to a half an hour to get as much of that pre-lab stuff for this lab report done as possible. Because tomorrow, I'm not talking about any of it. We're going straight across the hall to the lab and getting started because we only got 50 minutes tomorrow. Okay, so I didn't want to have any of this going on tomorrow when we need to just look at the stuff.